In this question, it's asked to find the current through each branch of the circuit. Basic rules used for solving this is the current rule and the loop rule. They given the arrow mark, but they didn't mark the current. So marking the current coming from 12 volts I1, that will go as I2 down and I3 right. So at B, we apply the junction rule. The current entering to B is I1, current leaving is I2 and I3. So current entering I1 has to equal to current leaving I2 plus I3. The currents are given I1, I2, I3 like different in different branches. First point is you have to apply junction rule, equation 1. Now go for any two loops because there are 3 unknowns. We need 3 equations to solve. So for a cell, negative is the small terminal, the long one is positive. For a resistor, current always go from positive terminal entering and negative terminal leaving. Arrow mark is down, so current is entering positive, leaving negative. The current is going from right to left, so it's plus and minus. Long one is plus, short one is minus. So if we go to A, B, E, D, A. A to B, I1 into 4, but the leaving terminal is negative. A to B, from A, it's enter through positive, leave from the negative. So minus 4 times I1. B to E, again, B is entering through positive, leaving from minus. So minus 3 I2. E to D nothing. D to A. D is entering through minus, coming out from plus. So plus 12 equal to 0. So if you transfer I1 and I2 terms to the right side, 12 is equal to 4I1 plus 3I2. Equation number 2. Now going to the next loop. B, E, F, C, B. B to E, it's entering through positive and leaving from negative. So minus 3 I2. E to F, it's entering from negative and leaving from the positive, E to F. So plus 2, the current in that branch is I3. Now F to C, entering through the negative, leaving from the positive of the cell. So plus 8. C to B, nothing. So this should be equal to 0. So if you rearrange it, 8 will remain there. 8 is equal to 3I2 will go to the right side as positive, minus 2I3. Equation number 3. Now this equation is in I1 and I2, this is in I2 and I3. We can substitute for I1. So using equation 1 in 2. 1 in 2 will give you 12 equal to 4I1. So 4I2 plus 4I3. So I1 is substituted as I2 plus I3, 4I2 plus 4I3 plus 3I2. So 4 plus 3, 7I2. 12 is equal to 7I2 plus 4I3. Equation number 4. Now there's a 3I2 and 2I3. So if you multiply equation 3 by 2, equation 3 into 2 will give you 16 is equal to 2 into 3, 6I2 minus 2 into 2, 4I3. You add both. 4I3, 4I3 get cancelled. 6 plus 7, 13I2. 16 plus 12, 28. Now I2 will be 28 by 13 ampere. You can substitute I2 back in one of the equations. So equation 3, if you rearrange equation 3, 2I3 will go left, 8 will come right. So 2I3 is equal to 3I2 minus 8 is equal to 3 into I2, 28 by 13 minus 8. That's for 2I3. So you can divide by 2 everywhere. I3 will be equal to 3 into 14 by 13 minus 4. Divide everywhere by 2. Now it's equal to 3 into 14, 30, 42 minus 4 into 13, 52. Divided by 30. 42 minus 52 minus 10 by 13 ampere. Side 3 into 14, 3, 10, 30, 3, 4, 12, so 42, 4, 13, 4 into 10, 40, 52 by 30, so minus 10 by 30. Now I1 is equal to I2 plus I3. So I2 is 28 by 13. I3 is minus 10 by 13. So together will become 18 by 30. That's for I1. So these are the currents for I1, I3 and I2.